What's up, YouTube? My name is Johnny Bandon with Trepid Technologies, and today I'll be covering authentication with named EIGRP. Like all my videos, we're going to be following Trepid Technologies' Confluence how-to page. So click the link below and let's have some fun. Alright, like always, we're going to start on our Confluence page. So this is Trepid Technologies Atlassian.net, and this is our Confluence page. This is where we store our documents, and for you out there on the internet, you'll be able to see our how-to space right here. So go to Spaces, click How-Tos. Right over here, we have all of our pages. I try to set my pages up like how you would see on Cisco's website. So Cisco, and then routers, and then different implementations. So since this video will be covering this how-to page, I'm going to follow this step by step and show you guys how to do authentication with EIGRP and even do some Wireshark action. So the first thing I'm going to do is go to the repo I use for source control management for all my at-home labs. So I use GitLab. Then I'm going to copy the URL because I need to clone this whole repo right here. Now I'm going to open up VS Code. Let's go ahead and just close this folder. We're going to go to View, Command Palette, and we're going to git clone. So I'm using Git as my source control, and GitLab is the web-based Git interface I'm using. So my home could be the repo location. Here we see it cloning. Once it's done, we can open it up. And here we go. So again, now that I have this repo, let's go back to our Confluence page. Let's see our first step. Step number 1 is set up our GNS3 environment. So boom, I have this here. Step number 2 is put a base configuration on our 8 and our 10. So these are the two routers we'll be setting up authentication. So let's get into these. So if you guys have been following my other videos, you know that in VS Code, on my CCIE_enterprise repository, this is where I house all my baselines. Right here, router base config. These get generated using Ansible. So I use Jinja templating and role-based folders to actually generate a unique base configuration for all my routers in the topology. So I need our 8s and our 10s base config. So what I did to make it easy for us, or for my lab, is in router 10 and router 8, I set up an applet that gets applied using an alias called baseline. And what this applet does is it goes in and it's going to get rid of all the routing protocols. So when I type in baseline, there should be no routing protocols left, but all my other base configuration is. So we'll do this on both routers. Now we do this to make sure that no other routing process is messing us up. Let's go back to our Confluence page. Third step is configuring named EIGRP. Easy enough. I'm going to go through this kind of quick, because if this is a little too fast for you, refer back to my other videos. So let's do it. Named EIGRP. Put in our networks. /16 wildcard mask. Easy. If I wanted to, I could just do this on router 10, do show run pipe section router. I could just copy this right here, paste, and boom, now we're done. And now we have EIGRP neighbors. Let's go back to our Confluence page and see what's next. Now for authentication, we're going to create a keychain. So let's take a step back for a second. Authentication in EIGRP, a lot of people get this confused. It's not actually encrypting or protecting any packets. All it's doing is that between routers in an autonomous system for EIGRP, it's sending a key phrase challenge. So what does that mean? If I'm router 10 and you're router 8, we both needed to agree on an authentication key to be able to send hellos and become adjacent and neighbors in EIGRP. So this is in the EIGRP hello packet, another little flag called authentication with your hash or your key that could be plain text or hashed. And once you agree that you have the same key, then you become EIGRP neighbors. You're not actually protecting any of the information in the EIGRP packet or in your data payload. So with that in mind, let's get configuring. So on router 8, the first step we need to do is create the keychain. This keychain can hold more than just the keys for EIGRP. You could have key 0 to whatever this crazy number is. For this keychain, we'll just be configuring the EIGRP key. So here's the part that matters, the key string. This has to match on both sides. The actual keychain name is irrelevant. It's all local to the router. And now we're going to do accept and send lifetimes. So this is the time and date that the router will either accept or send this key. So we're doing it from the beginning of the year till infinite. So if we get a key from our neighbor with a timestamp date that is before this date, then we will not accept that key. And we're going to go ahead and send the same lifetime. So that means we send this key and we'll stamp it with this date to infinite, so forever. So what could be the problem here? If your clock isn't synced on both routers, right? Let's say my clock is 1993. I didn't set the clock, I didn't set up NTP. Well, when I get a key with the right timestamp date, and I have this accept lifetime here, we will not become neighbors because that key won't be accepted. Because the router thinks it's in 1993 and it has to wait those 27, 28 years to start accepting a key. So for this to work, you have to make sure that your clock is synced. So we're going to do the same thing here. And just to prove that these keychain names do not have to match, I'll name it Johnny. We'll do our key string. This is the one that has to match, so lowercase Cisco. We'll do our send lifetime and our accept lifetimes. To infinite. And then we'll just come over here, accept. Awesome. So now what's our next step? Let's go back to our Confluence page and look. Now we have to apply the keychain and the hash to the actual interface, sending the hello packets, the actual interfaces that are becoming EIGRP neighbors. So on router 8 and router 10, that's gig 00. So type in do show run. I'll do a / to search for my EIGRP. Copy. Paste this. Now to get into the interface, under named mode, we type in AF-interface in the interface. Then to do authentication, we type in authentication. Then we have to specify two things. The keychain we want to use, which will contain our key 1, the key string Cisco. And we have to choose how we're going to hash this key. So we'll just do MD5, keep it simple. And this has to match on both sides. Here we see our neighbor went down. And that's because router 8 does not have a key. Router 10 has a key. And the hello packet, this router 10 needs to receive one back from router 8 with the same key. So let's actually go into Wireshark and see this at the wire. Start our capture. Sometimes Wireshark doesn't like to start right away, so we'll start it from here. Alright, so let's look at this hello packet from router 10. We'll go to the EIGRP header, and here we actually see authentication. Sound away a little bit. Here we see the hash type, then the actual digest, so that's our actual key right there. Now if we go look at a hello packet source from router 8, where authentication is not configured, we don't see that extra header on there. So these will not become neighbors. Let's go back to GNS3. And now let's configure authentication on the interface connected to our EIGRP neighbor. So we know we need authentication, the keychain name, EIGRP, and now we need the hash. This has to match on both sides, MD5. Now let's go back to Wireshark and see what we got. Now we see neighborship coming up. Go back to the packet source from router 10, and there's our authentication parameter. Actually, let's look at one source from router 8, excuse me. And there it is. Now they're both doing authentication. That is all there is to authentication, guys. It's very easy, very simple. The way it could get a little tough or even more intricate is that in an enterprise environment, we have key rollovers. So what does that mean? Well, you saw that accept and send lifetime. Usually, in an environment or enterprise that's practicing good cybersecurity, that key will change either monthly or yearly. So as a network administrator, it's up to us to make sure that that key rollover, so when I type in key 1, key string Cisco, and then I put key 2, key string Cisco 1, that's my new key for a different send and accept lifetime, I gotta make sure that all routers roll over to that new key, or we won't have neighborship in our autonomous system. So there's a couple different ways we can automate this. We can either make all the keys and have it roll over on its own, which isn't the best practice, because then the key's actually in the running config, right? Doesn't really matter, but there's other ways to do it as well. You can automate it through a playbook in Ansible. You could write a Python script using the NetMiko and ParaMiko libraries that goes in and configures a new key to a certain time, right? Or we can even make an applet that is also time-based that will apply once a certain time on the Cisco's clock actually reaches it, right? So it can get a little bit more intricate, but as far as basic authentication for EIGRP neighbors, this is it. So again, thank you for viewing this video. We appreciate you here at Trepid Technologies. And remember to keep learning every single day. Thank you.